They try to access the federal financial. Which will only be available to users of the app in the U.S.
Good morning. My name is Amber, and I will be your conference operator today. At this time, I would like to welcome everyone to the APM Global Community Webcast, Error Detection Conference Call. All lines have been placed on mute to prevent any background noise. After the speaker's remarks, there will be a question-and-answer session. If you would like to ask a question during this time, simply press star, then the number 1 on your telephone keypad. If you would like to withdraw your question, press the pound key. Thank you, Mr. Gunther Grossberger, Senior Engineering Service Architect. You may begin your conference.
Thank you, Amber. Good morning, everybody, and welcome to a new part of the APM Community Webcast series. Today's topic is error detection, and I hope that most of you have attended the custom instrumentation training, because this is going to be based on the things that Shrikant presented last time. So my name is Günther Grossberger, and like Shrikant, I'm working as a Senior Engineering Services Architect on the APM SWAT team, and most of you may know me from my entries and my contributions here in the community. So this call we'll try to keep it short as possible, so it will not go the full hour. And the agenda for today is, first, which errors will CA APM detect and which not, then how you're gonna see those errors that we do detect, how you can add your own errors to, so customize the error reporting so that errors that we don't catch out of the box will show up. And I'll be also talking to a very closely related topic, stalls, and what you can change in the configuration files for errors. And of course, you can ask questions at the end of this call, or you can post them in the chat while I'm going through the presentation. So the first topic I'm going to cover is which errors will CA APM report. So we're using bytecode instrumentation for your Java.NET and similar techniques for Node.js and PHP applications. So in order to be able to detect an error, the error must occur in a method that is instrumented with an error tracer. So the best known error tracer is the exception error reporter. If you look at your errors PVD, you will see some entries, or you just can grab or find in your PVD files, and you will also see instances and references to the other error reporters I'm showing you on this page. The second condition is that we only detect and report errors that are thrown out of the method. So it must be an exception. It must be thrown out of the method. In most of the cases, there are a few exceptions to this rule. For example, the HTTP error code reporter just reports an error when HTTP servlet response send error is called. But in the general case, it must be an exception that is thrown out of a method that we monitor. So the negative test, when will we not report errors? Of course, if it's in a method that we do not instrument with an error tracer. And of course, everything for Java and .NET applies. So if the exception, if the error originates in a method that we do not instrument, but it's not caught or rethrown, and finally ends up being thrown out of a method that we instrument, then we will catch it. One of the most common misconceptions is that the blame point tracer contains a metric errors per interval. And the blame point tracer, if you just put it on a method like Shrikant explained last week, or the last time, about a month ago, it will report an errors per interval metric, but this metric will always be 0. You won't catch any errors. We won't count any errors with the blame point tracer alone. So you need to add the exception error reporter to get values for the errors per interval metric and to report the errors. If an exception is thrown by some method and it's caught and handled inside the method we instrument, we will not be aware that the exception even occurred. So it's not thrown out of the method, it's handled. So for us, it's not an error condition. The developer handles the exception inside the method, so that's okay. Also, what we cannot detect if errors are out of the box. What we cannot detect out of the box, I will later cover this topic, how you can make this possible. But if an error condition is not returned or is not signaled by throwing an exception, but by a return code, for example, returning -1 or returning something else, we cannot detect this with out-of-the-box instrumentation. With custom error detection, we will be able to cover that scenario. So on to the next topic. Now we've covered what we can detect, and now how will you be aware that an error happened. So the first thing, if, for example, exception error reporter detects a exception thrown out of the method, it will increase the errors per interval count for that interval, or in the case if it's web service, SOAP web service call, it will increase the SOAP faults per interval metric. And this will happen only for the method where the error is detected, plus for aggregated methods, for example, web services, and for the front end and for the back end, not anywhere in between. So on the bottom half of this slide, you see a transaction trace snapshot, and transaction traces will be highlighted in red for those methods where an error has occurred. So you see at the top we have front end. So if an error occurs, it will be aggregated at the front end level. And you see down below we have 2 lines for web services, and one with just simpleMath.com, just the namespace, and one with simpleMath.com/process, the namespace and the operation name. And I said that usually errors do not aggregate up, but in this case it's 2 times the same tracer on the same method, just the name formatter is different. One name formatter includes the operation name process and the other does not. So therefore you have two red lines, 2 methods with the error, because they are both traces. There are 2 traces with different name formatters on the same method, and therefore they both are red. But the methods in between, the servlet access servlet and the do post method of the access servlet, they do not show the errors. So errors will only aggregate up at the front end level and not anywhere in between. Also, if you look at the bottom of the screen at the properties of this trace, you see the error message. So you see that it was an access fault with the error message invalid math operation that was thrown out of math simple backend stop process. And this is how it looks in the metric tree in the investigator, so we have an increase in the errors per interval metric, and if you have a table, it will show up. There are some thresholds on the tables out of the box, so that errors will show in yellow and red. And on the right-hand side, you can also see that there was one stall a little bit later than the two single occurrences of an error into intervals, and I will handle stalls later. You all should be familiar with this. So the second thing that happens when APM detects an error is that an error snapshot is created. Error snapshots are shown in the Errors tab, and error snapshots are events just like transaction traces. So errors, stall, events, and transaction traces, they all fall under the group of events that you can search for in the workstation with historical events query, and they will show up like this. So again, you see the error message in red at the bottom. You see where the error has occurred, and you see all the whole call stack down from the front end, in this case, down to where the error occurred. And since APM 9.7, as part of the smart instrumentation, this will also include deep components. So you see that we have two components, math rest proxy, math process method, and the math simple backend stub process method. Both of them are not instrumented by a PVD, but by smart instrumentation. The third thing that we will show is, since APM 9.7, we will also generate a transaction trace. So you will not only have the error snapshot as you had before, but also a transaction trace. A transaction trace that has an error is marked with the red X in the overview, in the list view, and in the trace view. You already have seen the bottom part below, and this error is also propagated to the calling JVM, and with the Thunderbolt sign, you see also the deep component from smart instrumentation on the stack. So we have three things. We have the errors per interval metric, we have the error snapshot, and since 9.7, you have automatically a transaction trace for an error. So what do you do if you know there are errors in your application, if, for example, from a log file, but they are not shown with APM? So the first case is that it's a custom method that usually has no tracer, and for example, in this example, it's myController.handle. So we want to also show errors that are thrown out of the handle method, and the error message that you will see with this method is the exception get message. So you have to add 2 lines to your custom PVD. The first is to identify the class, and that's my controller. And the second thing is you need to assign a tracer to the handle method, and the tracer that we assign is the exception error reporter, and then a string for the metric name. And one very important thing, you always have to use the with parameters variant of the directive. So if you just do a trace1 method, it's flagged, you won't get an error snapshot. because only if you use with parameters, the exception information will be handed over to the error and to the tracer, and so the exception error reporter can evaluate the exception. So always use with parameters if you do an exception error reporter. The second use case is you have a custom exception in your application and you want to know when your exception is thrown, when your exception class is instantiated. So for this, we also have a solution and the code is below. So what we do is we use this error reporter tracer and put it on the init method. So when that's basically a code for the constructor. So when my custom exception is constructed in the code, this error reporter will increment the errors per interval metric, and the error message will be the toString method of the exception. The third use case is that you have some kind of method that is called if an error condition occurs. For example, a method my controller on error. So every time I have an error in my controller, I call on error and do the error handling there. And you want to count this and generate error snapshots for this condition. So you could use a method called error reporter, and again, same thing, directive, use with parameters, use the on error, use the method called error reporter, and it will increase the errors per interval metric anytime that on error is called. And the fourth use case is, like I said before, you have any other condition than the first three use cases. So for example, you have a return code or some other thing that is either in the parameters of the method we call, or the return code of the method, and we can implement a custom tracer that we can also use to create an errors per interval method. But doing a custom tracer there is an API for it, but that is typically work that we in the SWAT team or CA services does, or maybe a partner, but typically not what we encourage our APM users to do. So to summarize, we have four use cases. We have additional methods that an exception is thrown out of. We have custom exceptions that we want to track. We have error methods that we want to track, or we have the most custom use case of a custom error tracer. The next topic is stalls. Stalls are kind of related to errors. They fall under the same category. They are both events, so something that's happening in my application that might tell me that something is wrong with my application. So what is a stall? A stall is defined as invocation of a method or a component that takes longer than 30 seconds. And this can be a Java method, this can be a .NET method, this can be a web service call, this can be a database call. Every time that something takes longer than 30 seconds, a stall will be generated by CA APM. And the good thing about stall is that it is a proactive problem indicator. I will go into that on the next slide. And what we do is, for a stall, we create a stall snapshot, like we do create a error snapshot for an error. We increase the stall count metric, but we do not generate a transaction trace. And again, in the stall snapshot, you can see the call stack, and the error message will always be stalled transaction. So why did I say that stalls are proactive indicators? So we have come up with kind of terminology. So what you look at, if you're very reactive, you look at log files, you look at process pingers, you look at heap and thread dumps, but this is always an investigation way after the fact that something has happened to your application, some performance problem has happened. Lagging means most of the time you will be aware that the problem has happened and more or less shortly after it, but a response time metric only will increase and only will report it if the method has returned. So if you have a call to the database that times out, you will, or that takes a long time, a 40-second query, you will only be notified of the response time after the query has completed. The good thing about errors are reported as they occur, and also stalls are reported early. So the stall mechanism basically works like this. Every 10 seconds, and I will show you later on, you can configure that, but I would leave it at 10 seconds. Every 10 seconds, a APM looks at all the threads that are running and checks is this thread still in the same method it has entered more than 30 seconds ago. If this is the case, it will be reported as a stall. So you will be aware of the fact that something takes long while it's still working, while the database is still working on the query, or while the web service is still looking up some data or constructing some data, but you will be notified before the method returns, only if we notice that it has taken more than 30 seconds. So this is a good indicator, and typically if you have some kind of bottleneck problem, stall count is the best indicator to detect this resource bottlenecks as early as possible. So what can you do in the APM configuration about errors? The first thing is, and that's out of the box, you can enable error snapshots, or you can disable them if you really want to. We don't want to overload the APM infrastructure with error events. So if some component goes down the drain and creates a lot and a lot of errors, we will only report the first 10 error snapshots. We will count all the errors, but we will only create 10 error snapshots per interval per agent. And on the other hand, if you have an application, and oftentimes this is the case, that exceptions are thrown on one level and are handled on another level, and we just report all those harmless exceptions. You can ignore exceptions. So you can add a line or several lines to the configuration to ignore error messages that contain a certain text. So for example, this harmless exception, or you don't want to be notified of 404 errors, find that line, edit the expression at the end, and test it. The second part of this configuration is about stalls. So by default, and I would very much recommend not to change it, the stall threshold is 30 seconds, so everything that, if a method invocation takes longer than 30 seconds, it is reported as a stall. And every 10 seconds, the so-called stall sweeper goes through all the threads and looks for stalls. And the two last configuration settings are enable deep tracing, so smart instrumentation, reporting of additional methods where we have no tracer configured, but that we detected with smart instrumentation. You can turn that off with those two settings. So, yeah, in this 25 minutes, I've given you a hopefully concise and comprehensive overview about error detection in CA APM. If you didn't fully get the part with the custom error detection, take a look at our custom instrumentation webcast. And with that, I'm finished with my presentation. And Amber, if there are any questions.
At this time, I would like to remind everyone, in order to ask a question, press star then the number 1 on your telephone keypad.
If there are no questions, Melanie Giuliani from our community team has opened a poll to rate today's webcast, so please give us your feedback, how valuable this was to you, and we will post a recording and we will post the slides of this webcast on the community, and if you have any questions, you can also answer there or give us your feedback.
And there are no questions at this time.
All right, in that case, thank you so much everyone for joining. Thank you, Gunter, for the fantastic presentation. Keep an eye out in the APM community for upcoming webcasts, and thank you everyone for joining.
This concludes today's conference call. You may now disconnect.